We know the process. We know how it happened. We know how stars are formed. We know how planets exist. We know how gravity is affecting the planets around them. We know so much about all this. We know so much about the process of going from single-celled organisms to multi-celled organisms and photosynthesis existing, and that fungus exists in a completely different way. We know so much about all the things that absolutely came out of the universe itself. Why not assume the universe is God?
I mean, it is in some technical sense.
It has to be. It's everything. The universe is everything, including God. If God is a real thing.
If you define God as the creator,
yes,
then you're right. From some point that we don't understand, by the way, the Big Bang. We don't even understand whether that was the origin of the universe, by the way. We understand that something interesting happened.
What is Sir Roger Penrose's? He has
an infinite cyclical universe.
Yes.
And he's trying to answer questions about the very special state of the early universe and why it was the way that it was.
So his model is an infinite contraction and expansion?
It doesn't really contract. It's called, what's it called? Conformal cosmology, or cyclical conformal cosmology or something. So it's essentially that, and I don't fully understand it, and I have asked him about it with some colleagues, actually. None of us understood what he was talking about.
We're fucked.
No, I don't think many of us understand what he... Roger Penrose is one of the greats, right? So you listen to him and take him very seriously. But I haven't met anyone who quite understands what he's talking about in that. But it doesn't recontract. It's not one of those models where the universe expands and then recontracts and bounces like that. It's not one of those. It's somehow, he argues, that when you get to what we usually call the heat death of the universe, where even the black holes have evaporated away, you have conditions that begin to look perhaps like an origin of the universe again. And I can't really fully explain it because I don't really understand what he's trying to say, right? And
wow. So it's not a contraction; it's an infinite expansion, then some sort of a metamorphosis.
Yeah, it kind of looks like conformal means there are no sort of distances or time measurements or anything in the universe. It kind of loses all sense of scale. And then you could reimagine that as looking somewhat like the beginning. It's something like that he has in mind, but I really couldn't explain to you. I don't understand what he's proposing.
Wow.
There. So what it does tell you is that we don't know why or how the universe got into the state that we call the Big Bang. So we don't know whether the universe existed before that. We have theories that it did, theories called inflation, which are very popular theories. You'll find them in all the textbooks, which say that before the universe was hot and dense, which we used to call the Big Bang, space and time is still there, and the universe is expanding extremely fast. It's called inflation. And then that period draws to a close, and that expansion sort of slows down and almost collapses and changes. And the energy that was driving the expansion gets sort of dumped into space and changes and ultimately makes the particles out of which we are made. So that's actually the standard model of cosmology now. So we do have an idea that we redefine the Big Bang as the hot Big Bang, and it's not the origin of the universe in time. It's the end of inflation. And then you get the question, what is inflation? Did that have a beginning? And the answer is that in Einstein's theory alone, then yes. And Roger Penrose actually and Stephen Hawking proved this a long time ago, that just given Einstein's theory, you have this singularity, just kind of like the black hole singularity, but at the beginning of time. But we do know that when you put quantum mechanics in and add that in, then it gets messy and we don't really know what that means. And so Stephen Hawking had a thing called the no boundary proposal. There's all sorts. Basically, the point is we don't know. So we don't know whether the universe had a beginning in time, I would say is the correct statement as we are at the moment. It's part of the reason why, by the way, getting back to the black holes, they're important and interesting, because the study of black holes and this idea of information and how does it get out, that's leading us to suspect that space and time themselves are not fundamental, but they emerge from something else. So just in the way that we've been talking about consciousness emerging from this physical structure in our heads. So we don't know how it emerges. It's a very strange thing, but it emerges from this collection of atoms, right, in a particular pattern. Well, we think now, from the study of black holes, that space and time emerge from something else, which is kind of one way to describe it is just a quantum theory. So it's in quantum computing terms, it would be just qubits. So a network of qubits entangled together, just like a quantum computer. Out of that, we suspect that space and time might emerge. So surely we have to understand that process, and we don't really fully understand that, but we have glimpses of it in much more detail to start talking about the origin of time. Because in order to talk about the origin of time, you have to know what it is. And we don't actually know what it is, which is, and that's kind of, when you say that, it sounds bizarre, doesn't it? Well, how can you not know what time is? I think Einstein once said that it is the thing that you measure on a watch. But he said that as kind of almost a joke, because you assume in Einstein's theory there's a thing that the watch measures. But what actually it is, at the deepest level, is a good question. So, but it's funny, it's interesting that study of black holes is forcing us towards these theories. It's not that we had the theory, space and time emerging from something, and decided we could check it by thinking about black holes. It's come the other way round, really. So it's interesting, but that almost makes the universe look in some ways like a giant quantum computer, which is not to say that we live in a simulation. Before you ask, but it just looks like there's a description of the universe that looks like a quantum computer type description. Now that doesn't have the concept of space or time in it.
Is it possible that that is what it is, and that the universe was created, and that as we're talking about, super intelligent life forms keep constructing better versions of itself and better versions of computers to the point where it can construct the universe itself?
I mean,
if we're seeing the code, if we're seeing the evidence, we're seeing something that mimics a quantum computer in the universe. We're like, couldn't be that.
It is. It's interesting that you're right, and that's a good way of phrasing it. Mimics or looks like a network of qubits. So it looks like some kind of quantum computing description is available to us for the universe. But I don't think you can infer much from that.